Hello everyone, how are you? Myself Nilesh Prasad and I'm welcome you all in my YouTube channel. Today we are discussing about the new topic of bioinorganic chemistry and the topic name is myoglobin. Okay, first we discuss about the myoglobin, but that topic are include in the oxygen storage and oxygen transport system. Okay, what is the oxygen storage and oxygen transport system? Basically, myoglobin, hemoglobin, hemathrine and hemocyanin. There are four different type of oxygen storage and oxygen transport system will be there. Okay, in four there are two types will be heme group and two are non-heme group. Okay, basically heme group is connected with the ferrous, like ferrous iron is connected with the porphyrin ring. Okay, and in non-heme group metal will be there but they are not connected with the any porphyrin ring. Okay, this is a simple difference between the heme group and non-heme group. Okay, now we discuss about what is the myoglobin, what is the structure of myoglobin. You can clearly see the structure of myoglobin. Okay, but this is you can see in that structure there is no oxygen will be present. Okay, and myoglobin also can be categorized as the oxymyoglobin. Okay, what is the oxymyoglobin? Oxymyoglobin is you have simply included oxygen in myoglobin. Okay, and the this whole procedure is known as the like oxidation of myoglobin. Okay, if you having a non-oxidized myoglobin, then you have to simply add the oxygen molecule. Okay, and then after adding the oxygen molecule into the myoglobin, then it converted into the oxymyoglobin. Okay, now first we discuss about the myoglobin. Oh, what is myoglobin? Correct. Here there are some point will be there for the myoglobin, जिससे आपको बहुत क्लियर तरीके से ये सारी चीजें बहुत अच्छे से समझ में आ जाएगी. Okay, actually the myoglobin specially present in the tissue. Okay, you can see there are small tissue present in animals. Okay, in human being. Okay, and in that tissue the myoglobin are present. Okay, it is present inside the tissue. Correct, this is the first point for myoglobin. What is the second point? Okay, second point is we already tell them ki if myoglobin contain the oxygen. Okay, it adding the oxygen into that, then it converted into the dioxygen form. Okay, storage the dioxygen. It also store the dioxygen, and dioxygen is represented as O2. Okay, not O. Third point is uh, in myoglobin the heme unit present. Heme unit is present in myoglobin. Okay, what is the heme group? Heme group is the combination or the sum of iron plus porphyrin. Okay, in every oxygen storage unit there are four porphyrin ring will be present. Okay, except heme group. Okay, in non-heme group there are no porphyrin ring will be present. Okay, some other group are present in non-heme group. Okay, in heme group only the porphyrin ring will attach to the fair iron. Okay, and if the iron is attached to the porphyrin ring, then it's called as the heme group. Okay, fifth point is histidine unit is also present. Okay, and the sixth point is the structure of myoglobin is alpha helix structure. Okay, and in alpha helix structure there are 153 amino acid will be present. Amino acid nothing but the uh, amino acid converted protein. Okay, they are formed protein with the help of forming the chain. Okay, there are 153 amino acid are present in alpha helix structure. Okay, now move to the myoglobin. Like next point for the myoglobin is there are two type of myoglobin are generally seen. Okay, and the first one is deoxymyoglobin and second one is oxymyoglobin. Okay, what is the deoxymyoglobin and what is the oxymyoglobin? You can see the clear picture of myoglobin and clear structure of myoglobin. This is a example of deoxymyoglobin. There is no directly oxygen is connected to the metal atom. Okay, but I can show you the oxymyoglobin. Okay, in there the oxygen is directly connected to the metal atom like iron. Okay, and is called as the oxymyoglobin. Simple structure, you can simply divided the myoglobin into the two form. First one is deoxymyoglobin. Okay, deoxy, अगर आप सिंपल सा अगर आप नाम भी देखोगे ना तो भी आपको बहुत क्लियर तरीके से यहाँ पे ये सारी चीजें समझ में आ जाएगी. ओके, नाउ आई हैव टू राइट डाउन फर्स्ट deoxymyoglobin. Okay, and second one is oxymyoglobin. Oxymyoglobin. Okay, and what is the difference between the deoxymyoglobin and oxymyoglobin? I can show you the first image of the deoxymyoglobin. Okay, and you can clearly understand what is the deoxymyoglobin. Okay, deoxymyoglobin also is connected ferrous into the porphyrin ring. You can see this is a ferrous atom. Okay, and they are connected to the porphyrin ring. Okay, and histidine, correct, and there are four porphyrin ring will be present, and histidine and histidine. Okay, and all the histidine will be connected with the CH group. Okay, you can see in a real image of myoglobin they are connected like this. Okay, uh, in CH bond. Okay, this is a bond for connected with the nitrogen and nitrogen. Okay, and in this whole diagram, okay, one major histidine will be present. Okay, and is this histidine is directly connected with the ferrous atom, and this is called as the deoxymyoglobin. Okay, in deoxymyoglobin I am simply adding the oxygen molecule like the dioxygen molecule O2. Okay, and now the structure will be converted into the oxymyoglobin, and the structure is Fe. Here one histidine group will be present, porphyrin ring. Okay, and this is the second porphyrin ring, correct, and this one is third porphyrin ring, histidine, and this one is fourth porphyrin ring connected with the. Okay, and now all the histidine group are interconnected with each other, correct, like this, and they are connected with the bond of CH. You can see in like this is a real image of myoglobin. You can see there are histidine will be present. Okay, one nitrogen, second nitrogen, third nitrogen, and fourth nitrogen. Okay, and with nitrogen the complete histidine group will be connected. There are four histidine group will be there, and if the nitrogen is connected with the histidine they call as the porphyrin ring. Okay, and in porphyrin ring there is no oxygen will be there in simple myoglobin. Okay, but after adding the dioxygen into that, the simple myoglobin is converted into the oxymyoglobin. Okay, in first picture of deoxymyoglobin you can see one histidine group is directly connected with the ferrous atom. Okay, now after adding the O2, okay, then it also connected with the ferrous. Okay, with the help of single bond oxygen and double bond O. Okay, there is O, there is two O is connected with the ferrous, and this structure is known to be a oxymyoglobin. Okay, and deoxymyoglobin and oxymyoglobin also you can differentiate with the different point, like In deoxymyoglobin you can see the ferrous will be iron will be presented in the +2 state. Okay, after adding the oxygen in myoglobin, okay, then it converted into the oxymyoglobin and the ferrous is converted into the +2 state to the +3 state. Okay, now I can write down the some points of deoxymyoglobin and oxymyoglobin. The first point of deoxymyoglobin is Fe present in +2 oxygen oxidation state. Okay, and in oxymyoglobin Fe present in +3 oxidation state. Okay, the second point for the deoxymyoglobin is uh, in this deoxymyoglobin you can see the high spin will be shown. Okay, high spin, and in oxymyoglobin low spin will be shown. Okay, and for Fe2 plus you can simply calculate the value of CFSC value. Okay, and for Fe plus 3 you can also calculate the value of CFSC value. Okay, now we are first calculating the CFSC value for CFSE value of F plus 2. Okay, Fe plus 2, and CFSE value of Fe plus 3. Okay, CFSE value of Fe plus 3. Okay, now you can see there Fe plus 2 is showing the D6 oxidation state. Okay, D6, okay, configuration in high spin. Correct. Now the D6 in that Fe plus 2 there are 6 electron will be present in the D subshell. Okay, and in D subshell there are the capacity of including the capacity of holding the electron in d subshell will be 10. Okay, if the 10 electron are holding by the d orbital and in Fe plus 2 there are only 6 electron will be present, you can simply arrange them into this different shells. Okay, like this is a d, and 6 electron will be arranged in high spin. Okay, 1 electron, 2 electron, 3 electron, 4 electron, 5th electron, and 6th electron. Okay, now the CFSC value of Fe2 plus is, you can simply calculate the CFSE value of Fe2 plus is minus 0.4 delta naught. Okay, and you can also find the value of Fe plus 3 or CFSC value. Okay, and this Fe plus 3 is also find in D6 configuration in low spin. Okay, correct. And in low spin you can see, sorry, there are Fe is also present in Fe plus 2 state. Okay, you can correct down here. If Fe3 will be there, then D5 configuration are there. Okay, and Fe plus 2 is also present in the D6 configuration, and D6 configuration is present in the low spin. Okay, and electron are arranged in low spin. Okay, electron can't move to the excited state. 1, 2, 3, 4, 5, 6. Okay, every time you fill the electron in the low spin, remember the one thing is in low spin there are electron are arranged in the pair form. Okay, the first arranged pair form like 2 electron in each and every block. Okay, and this is a final representation of Fe2 plus in low spin. Abhi simply I have to calculate the CFSC value for low spin. Okay, and the CFSC value of low spin for Fe2 plus is minus 2.4 del 0. Okay, now you can simply clearly see that the value of CFSC value in deoxymyoglobin and CFSC value of oxymyoglobin for Fe2 plus. Okay, the CFSC value of oxymyoglobin is much bigger than डीऑक्सी मायोग्लोबिन। ओके, तो यहाँ तक आई थिंक मेरे हिसाब से बहुत क्लियर तरीके से समझ में आ गया होगा। ओके, now on the basis of CFSC value you can also calculate the ionic radius of simple oxymyoglobin and deoxymyoglobin. Okay, on the basis of CFSC value you can say that if the CFSC value is low, okay, then the ionic radius will be high. Okay, ionic radii will be more. Okay, and in oxymyoglobin, if CFSC value is much high, then you can say that the ionic radius will be ionic radii is much small. Okay, and this is a final representation of deoxymyoglobin and oxymyoglobin. I can simply give the 3 to 4 point which represent the oxymyoglobin and deoxymyoglobin. Okay, you can see there are no change in their oxidation state but change in the spin. Okay, first one is high spin and second one is low spin, and the CFSC value for both are different. Okay, for deoxymyoglobin the CFSC value is very small, and for oxymyoglobin the CFSC value is very high. Okay, on the basis of CFSC value you can also calculate the ionic radius of that value. Okay, if the CFSC value is low the ionic radius will be high. Okay, if the CFSC value is high the ionic radius will be low. Okay, simply this is a simple representation of oxymyoglobin and deoxymyoglobin. Okay, now you can also say that there are also 2 3 points will be there, like you can also say that deoxymyoglobin show the paramagnetism. Okay, paramagnetic character. Okay, and the oxymyoglobin show the diamagnetic property. Okay, and it also show the ESR inactive. Okay, and in oxymyoglobin the oxygen is bind as the superoxide form. Okay, O2 is bind as superoxide form. Okay, and the reaction of superoxide is O2 is bind to the hemoglobin and their bond order is 2. Okay, and for O2 minus their bond order should be 1.5. Okay, and this is the final representation of hemoglobin myoglobin. Okay, in that we discuss about the oxymyoglobin and deoxymyoglobin. अगर फिर भी अगर आपको कहीं पे कुछ डाउट लगता है तो you can simply comment down below the video. Okay, and you can also contact me in my Instagram ID and my Telegram channel. You can share with your share your problem. Okay, एंड प्लीज डू नॉट फॉरगेट टू सब्सक्राइब माय चैनल, और अपने दोस्तों को भी ये वीडियो को आप शेयर कर दो। ओके, और थैंक यू सो मच फॉर वाचिंग माय वीडियो। मिलते हैं हम लोग नेक्स्ट वीडियो में नए टॉपिक के साथ, और नया टॉपिक भी हमारा बायो इनऑर्गेनिक का ही होने वाला है। एंड in next video we discuss about the hemoglobin, what is the hemoglobin, why they are important for our body. Okay, how the structure of a hemoglobin, how they form. Okay, this all point are discussed in the hemoglobin. They are also the good oxygen storage and the oxygen transport system. Okay, in that myoglobin hemoglobin oxygen is also combined with the hemoglobin and they form the oxyhemoglobin. Okay, these many points are discussed in hemoglobin. Thank you so much for now. Okay, see you in next video. Thank you so